We are going to talk about polynomials, and when we talk about polynomials we need to talk about several things. First, we need to know how to multiply them. We also need to know how to combine like terms. So I'm going to do maybe all the problems on here. We'll kind of know as we get into it if I'm going to do them all or not. Nevertheless, you're responsible for all of them, whether I do them or not. So let's begin with the first one, and it's going to seem very basic at first. So we have 4x to the third minus 6x squared plus 2x plus 7, and that's all one quantity because it's all in parentheses. And then 5x squared minus 2x. You've seen this before. It's just a matter of putting like terms together. Like terms, and I'm not going to write this down, but like terms have the same exponent with the same variable and exponent. Let me rephrase that. If I have x squared and an x squared, then they're like terms. Like this one and this one. They are like terms. I will be able to put them together. Negative 2x and positive 2x. Said that backwards, but they are like terms. So we'll simply just add them. And so we have, well, this is the only one of its kind. 4x cubed, no surprises there. Negative 6x squared plus 5x squared. So negative 6 plus 5 is negative 1x squared. 2x minus 2x, 2 minus 2 of course is 0, and there we go. That is our final answer. One of the obvious questions is, why are they even in parentheses? Well, they don't have to be, because the parentheses are grouping them, but it's not really doing anything significant. Okay, as we move to number 2, you'll see that the parentheses are important. So we have 2x to the third plus 8x squared minus 6x. And the reason the parentheses are important is because of this negative right here. So we have 2x cubed minus x squared plus 1. And we are going to distribute this negative 1 that's understood that's right here. Now technically here it's a positive 1. Multiplying by positive 1 doesn't change anything. But we can multiply by this negative 1 to all three of these terms, and it'll change a few things. So I'm going to drop parentheses at this point because it doesn't really hold any significance. 2x cubed, 8x squared minus 6x. I can put it in parentheses or not, doesn't matter. And negative 1 times 2x cubed, so negative 2x cubed. Negative 1 times negative x is positive x squared. Negative 1 times 1 is negative 1. And now we have some like terms to put together. So I'm going to underline them based on who goes with whom. So 2x cubed, negative 2x cubed, they actually cancel each other out. This one and this one are alike. And these two are not alike. This one has an x and that one does not. So you know this, but just be careful with it. So those two cancel. So 2 minus 2 is 0. Plus 1, 9. And then we have this term, and we have this term. And notice the exponents are going from highest to lowest in descending order, going down. So 2, 1, technically 0. Or in this case, 3, 2, there were no x to the firsts, and then none. Okay? The next one is a little bit tricky in that it has all kinds of things that look like they're like terms, but they're not. So I'm actually going to write it out like I did the last one, and then we'll kind of figure out what to do in terms of like terms and what's not like terms. So we have 9a squared b squared, a squared b squared, plus 6ab minus 3ab squared. Okay, before we go any further, let's just stop and stare at that. None of these are like terms. They all have a's or b's or both, but they don't have the same exponents. Like that's a squared b squared. There are no other a squared b squareds in here. So none of these are alike. And then we have minus 5b squared plus 2ab minus 3 minus 9b squared. And we will start by distributing a negative 1. So let's do it. We have a negative 1 right here, and we're going to distribute to all of those. And if you don't mind, I'm going to save a little bit of writing. Hope this doesn't offend you. I'm actually going to not rewrite it. Let's go ahead and just change the signs. When I distribute a negative, that makes this a plus. Changes that sign, that one, and that one. And so what I'm going to do now is go through here and find like terms. And I'll put them together if I find them. So I'm looking for a squared b squareds, because that's the first thing I see. 9a squared b squared, looking for a squared b squared. Oh, nope. That is the only one of this kind. If it helps, you can kind of gently mark them out because we're done with them. So we have AB. I'm looking for just plain old AB. 6AB, negative 2AB. So this one and this one are alike. So 6 minus 2 gives me 4. AB. Those cancel. We have negative 3AB squared. AB squared, AB squared. Oh, nope, nope, don't have it. We don't have it at all. So we can't put anything with that one. He's done. Negative 5b squared plus 9b squared. These actually were like terms to start with. So negative 5 plus 9 is 4b squared. Let's those out. And what do we have left? A 3 plus 3. Now, we could probably talk about the order in which these should go in terms of descending order, ascending order, but with two variables and so many different ways to put the exponents, let's just leave it like this. It's not worth the trouble. So the first three examples were adding and subtracting and combining things like that. So as we move on, we're going to review a little bit of what to do in terms of multiplication, like how do we deal with the exponents when we're multiplying. So the next handful of examples deal with that, and then we get into multiplying polynomials together, which doesn't seem very practical, but actually it is when you're dealing with variables and you're representing them geometrically like we're going to do at the very end. You'll see what I mean today. So we have 6x times 4x, and you might already know the answer to that. If you do, that's fantastic. 6x times 4x, I put 6 twice, my bad. 6x times 4x, I'm going to go ahead and put all the examples. Negative 7x squared times 2x to the 5th. Negative 7x squared times 2x to the 5th. Oops, I put it twice, my bad. So let's not do that, because that's a repeat. Negative 12x to the 5th times negative x. And then we get into some other stuff. So what we're going to do is multiply these together. And when we do, let's remember some of the rules that we had. We have a 6 and a 4. Those are the coefficients. And we are technically multiplying, so let's truly multiply. 24. And then x to the, well, 1 and 1, understood ones, and we'll add those together. So it's 24x squared. Okay, let's keep going. Negative 7x squared times 2x to the 5th. So negative 7 times 2 is negative 14. And then, let's see, x to the 2nd and x to the 5th. If you wanted to waste your time, you could write 2 of them, and then 5 of them, 2 x's and 5 x's. And then, in the end, you're going to have 7 of them, so it's x to the 7. Same thing here, only it's represented a little bit differently, and we have a negative 1, understood negative 1 right there, shaky 1, there we go. So negative 12 times negative 1 is positive 12. X to the, let's see, 5 plus 1 is 6. There we go. So there's those three, and then we get into ones where we have to multiply a monomial, mono means 1, a monomial times a polynomial with more than one term. And you'll see what I mean. So when we get to the next problem, you start with 7x times x squared plus 2x plus 5. 7x. X squared plus 2x plus 5. Okay. I'm going to waste your time just a little bit and stretch this one out. I know you know what to do, but for the sake of explanation for when they get harder, I think it's going to be worth our trouble if we go through it the long way this time. So 7x times that, 7x times that, 7x times that. 7x times x squared. If you don't want to write all this, that's fine. Plus 7x times 2x plus 7x times 5. A lot of this can happen in your head. But what we're going to do is that same process, only we have to do it 3 times. So 7x times x squared, well that's 7, and then we'll add our exponents. Plus 7 times 2 is 14. X to the, well, 1 plus 1 is squared. Let's do 7 times 5, 35, and x. And that's it. Yes, again, you can skip that step if you like. That's perfectly okay. But that's going to come in handy when we have some of the more complicated ones. All right, the next problem is very similar. I'm going to go very quickly through this one. And when I do, I'm going to skip that middle step that I just wrote. So negative 3x squared, 5x squared plus 6x minus 1. There we go. And let's do this. So we're going to have this times that, and this times that, and this times that, and here we go. Negative 3 times 5, x squared times x squared, x to the 4th, because we're adding the exponents. All negative 3 times 6. X squared times x is x to the third. Negative 3x squared times negative 1. Well, negative times negative is positive, and it's 3x squared, and that's it. Okay. So that's what happens when we have a monomial times, in this case, a trinomial. And you know a lot of your prefixes. So mono means 1, bi means 2, tri means 3, quad means 4. Usually when we get above a trinomial, we don't call it a quadrinomial or a pentanomial or anything like that. So we are going to multiply a binomial times a binomial. So that's going to be these four right here. And you've seen this before, and a lot of people call this foiling. I'm not going to get in a big habit of calling it that, because if we call it that too much, we can oversimplify that process. So m plus 4 times m plus 6. So here's the deal. What we're going to do is multiply everything over here with everything over here. So we have an m that's going to get distributed to both of those. And we also have a 4 that's going to get distributed. Now, I think you noticed what just happened here. We have two things multiplied by two things. We're eventually going to have 4 terms. We'll combine some of them and make them like terms. Well, they are like terms. We'll combine them. But we're going to have m times m times 6, 4 times m, and 4 times 6. And we're almost finished. We can put some like terms together. We'll pause right here. Later, we're going to take these apart. We're starting where we multiply. In the end, we're going to end up where we can call it dividing, but we're going to factor them. So if we don't understand this process, then things are going to be harder a little later down the road. So m squared, those two together are like terms. 6m, 4m is 10m, plus 24. Let me pause right here and say something that will come in handy in about a week or less. When we are factoring this, we're going to ask ourselves, oh, I need, what are two numbers that multiply to give me 24? You can go through a big long list of them, but I need them to add together and give me a 10. Just wanted to say that. That's going to come in handy later. There will be some questions that we'll ask as we guide through that process. Okay, for the next one, it's the same thing, only the numbers are a little bit bigger. All right, we have 3x plus 2 and 2x minus 5. And we are going to multiply it. So we are going to go 3x times 2x, 3x times negative 5. Let's just start there. So 3x gets distributed. Again, some people call this foiling, and here's the reason they call it that, just in case you've never heard it, I'm sure you have. We can multiply the first ones together, then the outside ones together, and then eventually we'll do the inside ones, and then the last ones. And that's why they call it foiling. Call it that if you like. But that won't work when you get a little further down the page. So 3x times 2x is 6x squared. 3 times 2 is 6. 3x times negative 5 is negative 15x. 2 times 2 is 4x. 2 times negative 5 is negative 10. Most of the time, but not always, the two middle terms are like terms, and we can put them together. So negative 15x plus 4x. Well, negative 15 plus 4 is negative 11. And eventually we'll have to factor ones like this too. But for now, that's what we did. Okay, when we get to the next one, we see that it doesn't look like a binomial times a binomial, but it actually is. So we have 2x minus y squared. So since it's squared, we technically have two of them. 2x minus y and 2x minus y. Squared means there are two of them. Now, a lot of people are tempted to be like, well, I'll square this and square this. Well, no, let's not. Let's write it twice, and then we'll do the same process that we've been doing. So we have 2x times 2x, 2x times negative y times 2x, negative y times negative y. Okay? 2x times 2x is 4x squared. 2x times negative y is negative 2xy. Negative y times 2x is negative 2xy. Let's put them in alphabetical order. Negative y times negative, well, negative times negative is positive. Y times y is y squared. And we do have some like terms. This one and this one go together. Negative 2xy minus 2xy. Negative 2 minus 2 is negative 4xy. And that's what we have. There we go. Okay, this was a binomial squared. The next one is going to be what we call the difference of squares. Once we're finished with it. It's kind of a special case, and it's one of those that we need to keep in mind about a week down the road when we start factoring. We'll reference this later. We have x plus 8 and x minus 8. I said it backwards. That's okay. And something fantastic is going to happen on this one that's going to be worth noting later on. So x times 8, and negative 8 times x, and negative 8 times 8, and x times x is x squared. Those are your first ones. The outside is x times 8. The inside is negative 8 times x, and then negative 8 times negative 8 is negative 64. And here's the amazing thing that happens. Those two together. 8 minus 8. Oh, they're gone. They vanish. So this becomes 0x. So I'm going to write an extra step. You can leave it out if you want. But x squared, 0x minus 64. Well, I have no x's, so why would I even write it? So x squared minus 64. There we go. Okay. Then we get to the next one. Now, notice up to this point we've had a binomial times a binomial. Two things times two things. And now we're going to have a binomial times a trinomial. So I can't call it foiling because there's no first, outside, inside, last aspect to it. But the process will be very similar. So we're going to have, let's see, t plus 2, t squared minus 4t plus 2. There we go. And we are going to distribute this to all three terms. And distribute this to all three terms. And keep in mind, I'm multiplying two things times three things. So this is going to get pretty big. We're going to have 6, if I said 9. We're going to have 2 times 3. We're going to have 6 terms here, and then we'll have a lot of like terms, and we'll clean it up. So t times t squared, t times negative 4t, t times 2. Let's do that first. T times t squared is t cubed. T times negative 4t is negative 4t squared. T times 2 is 2t. Okay? Then we'll have 2 times t squared, 2 times negative 4t, 2 times 2. And we'll go through that process. So we have 2 times t squared, that's 2t squared. 2 times negative 4t is negative 4t. Oops. It's that feeling you get when you know you've done something wrong. There we go. 2 times 2 is going to give me 4. There we go. And we're going to have some like terms here. So let's just go from left to right and find things that are like it. So I'm looking for t cubed. Oh, he's the only one. Done. Looking for t squared. There's one. There's one. So negative 4 plus 2 is negative 2. Done. 2 minus 8. Done. And that's the only one with no t. It's not British. That's Belgium. There we go. We ended up with a four-nomial, a quadrinomial, not really a word we used, but has 4 terms. Okay, the next one is very similar, but we're going to have some weird exponents going on, little slightly different exponents. And then the one after that's kind of crazy. So let's keep going. Pause this at any point that you need to. All right, we have 2y squared plus 5. And we have y squared minus 3y plus 4. And we're going to do the same thing. Notice we have 2 terms times 3 terms. 2 times 3 is going to give me 6. We're going to have 6 terms here. We'll clean it up. Probably have less than that when we're finished. But that's what we're going to have at first. So 2y squared times y squared. 2y squared times negative 3y. 2y squared times 4. All right. 2y squared times y squared is 2y to the 4th. 2y squared times negative 3 is negative 6y to the 3rd. This times this gives me 8y squared. Okay. Just worth noting, no like terms yet. I expected that. There we go. 5 times y squared is 5y squared. Oh, see those like terms? We'll deal with that in a minute. 5 times negative 3y is negative 15y. 5 times 4 is 20. Okay, looking for like terms. Look, there's a 4. He's the only one of his kind. You're done. There's a 3. He's the only one of his kind. There's a 2. There's another one. 13. 8 plus 5 is 13. 15. 20. There we go. All right. And that's it. Now, the next one. It's going to be kind of big. But the next one is a trinomial times a trinomial. So how many terms do you think it's going to have? Don't say 6. It's three terms times 3 terms is going to give me 9 terms. So I'm going to end up with this huge thing, and then we'll condense it down quite a bit. So don't panic. It's just going to be kind of big when we start, but then we'll clean it up pretty quickly. All right, 2x squared minus 3x plus 4x squared plus 5x minus 2. All right. Let's do this one little piece at a time. 2x squared times this one, and this one. All 3 of those. We'll just start there. So we have 2x squared times x squared. That's 2x to the 4th. I'm going to write a little smaller because I have 9 terms to fit in here. 2x squared times 5x is 10x to the 3rd. 2x squared times negative 2 is negative 4x squared. There we go. Let's move on. We have just distributed the first term. Now let's distribute the middle term. We'll switch colors here. I'm going to go green. Negative 3x times x squared. Negative 3x times 5x. Negative 3x times negative 2. Negative 3x times all that. So negative 3x times that is negative 3x cubed. This times that is negative 15x squared. This times that is 6x. Okay? And then we'll distribute just a little bit more. We're not quite done. We haven't dealt with the 4 yet, so we're going to take 4 times this, and this. There we go. 4 times x squared is 4x squared. 4 times 5x is 20x. And 4 times negative 2 is negative 8. Man, what a polynomial. That's okay. It's about to get much cleaner. Looking for exponents of 4. There's one. Nope. Only one of its kind. He's so lonely. Looking for exponents of 3. There's one. There's one. That's it. Okay, 10 minus 3 is 7. Done. Okay. Looking for exponents of 2. There's one. There's one. There's one. Negative 4 minus 15 is negative 19. Negative 19 plus 4 is negative 15. Well, go back to this one. All right, cancels those out. Well, doesn't cancel them out, but we'll mark them out. And then there's one, and there's one. So x's. So 6x plus 20x is 26x. And then he is the only one of this kind. The only one without a variable. Okay, there it is. Now, when we get to the polygons, we get into some different stuff. We are going to have some very different stuff here. It's going to get a little bit wacky. So I'm going to attempt to draw this picture right here, and we're going to go back to some stuff that we had done at the beginning of the semester. So let's suppose we have this building and it's shaped all funny, but we don't really have enough information to know the exact lengths of the sides, or maybe the architect hasn't completed the plans and he knows the proportions to a sense, that he has variables but not everything. Anyway, variables could stand for a lot of things. We have 2y plus 1 here. We have 2y here. We have y plus 4 here. And we have 5 here. And what I want to do, what we need to do, is find the missing lengths of the sides. We need to find the perimeter, and we need to find the area. Oh my goodness, this one's going to be crazy. That's okay. This one's going to take a minute. We've done it before. Here's what I don't know. I don't know that. I don't know the length of that top part, but that's okay. All I have to do is add together all the other horizontal parts. So I'm just looking, oh, there's a piece, there's a piece. So this piece plus this piece should give me that whole distance, which is the same as that. So y plus 4 plus 2y. I'm going to write that, and then we're going to kind of tinker with it a little bit. So we have y plus 4 plus 2y. Okay, so let's stop there. That's a mess. We can clean that up. When we have this, we really have some like terms. We have 1y and 2y. So in the end, we're going to just call this 3y plus 4. Then here's some like terms. See them? So I'm going to erase this in a second, but I don't need that anymore. I know what it is because I added together the other pieces that are horizontal. We're assuming everything is right angle here. So let's find this one. Well, let's add together this. Well, I don't know how long that is. Yes, I do. It's 2y plus 1. So 2y plus 1 and 5. So 2y plus 1 plus 5. Oh, you know what? That's messy. Like terms. Let's put them together. 2y plus 1 plus 5. That's 2y plus 6. Okay. I'm going to erase this. I'm going to erase this. And now we know the length of every side, at least in terms of y. So we are going to find the perimeter. And when we find that perimeter, all we have to do is add every side together. So I'm going to start just here, and I'm going to go around and write them all down. We're going to add them all together. It's going to be a mess, but that's okay. The perimeter is everything all the way around. 3y plus 4 plus 2y plus 1. Should I use parentheses? Sure, whatever. If you want to put that in parentheses, you can. Not necessary, but you can. Plus 2y plus 5 plus y plus 4. That's too much. Yep, it is too much. That's why we're about to clean it up. 2y plus 6. Okay. Looking for like terms, and we have a bunch of them. 3y, 2y, 2y, y, 2y. Oh my goodness. 3 plus 2 plus 2 plus 1 plus 2. 5, 6, 7, 8, 9, 10. 10y plus 4 plus 1 plus 5 plus 4 plus 6 is 20. The perimeter of this is 10y plus 20. There it is. I'm going to erase that because we need to find the area also. Area? Oh my goodness, how are we going to do that? I have a brilliant idea. A great idea. Let's do it. This one's going to get tricky. Oh, it's going to be fun. Let's erase. And when we do, start all over with the area, and let's kind of draw some stuff. Let's suppose that the building actually was a rectangle that came all the way out to here. If that was the case, then we would have a building or room or whatever it is that measures 2y plus 6 times 3y plus 4. So we have 2y plus 6 times 3y plus 4. But you know what? It doesn't measure that. It's not that big because there's a corner that's missing. Well, how big is our corner? Well, the area of our corner is rectangle, length times width, and, well, I said that backwards, but that's okay. Length times width, so it's 2y times 5. So 2y, I'm going to put it in parentheses, times 5, and I'm subtracting it. Okay, so here's the deal. There's this huge room, but there's a corner missing. So I'm going to subtract the area that's missing. I'm going to figure out what that is. Okay, so before we get all crazy with it, let's identify the parts, the components. If I wanted to find this area first, I would simply do a binomial times a binomial. Foiling, just foiling. And then we'll subtract this. Well, 2y times 5, that's 10y. So let's not get caught up in it. We got this. Let's see. 2y times 3y is 6y squared. 2y times 4 is 8y. 6, 3, 18y. 6 and 4 is 24. Minus 10y. There we go. So what we are going to do is put our like terms together. 6y squared. There's a y, there's a y, there's a y. 18 and 8 makes 26 minus 10 is 16. And then 24. That is the area of this figure. And if you knew what y was, you could plug it right in and figure out the whole thing. Okay, 2 more quick questions. And then from there, actually, those next questions are going to be easier than this one. So, I'm going to erase my picture. And we're going to move on to the next part that says there's this pasture, and it is a square, or it's a field, not necessarily a pasture. There's a square field, and we know it's X meters on the side. Let's suppose you don't know exactly what it is for some reason. You forgot how to measure, or you didn't measure, or you bought a field without knowing how big it was. Anyway, it's X meters on the side, and X all the way around. And it said 2 things, find the area and what is the perimeter. So the area of this, and it's easy to mix up if you're not careful. The area of this square is length times width. Well, it's X times X, which is X squared. That's not 2X. We're adding the X moments. Okay? The perimeter, on the other hand, is we're going to start in a corner and go all the way around. X plus X plus X plus X. X plus X plus X plus X. And when you do that, you have 4 of them. So there you go. Now, for the last problem, we're going to expand the field 4 meters on its length and 3 units, I meant to say meters, on its width. What is its area? What's its perimeter? So let's erase. This is the very last problem. And let's keep the picture we have. But what we're going to do is expand it. We're going to expand it lengthwise by 4. So we're going to go down 4 more. There we go, 4. And then we're going to go widthwise by 3. We're going to 3 more right there. And that is our new field. Let's erase. This is what our old field was, and this is our new one. So I'm not going to call this x3. I'm actually going to call it x plus 3. And this is no longer like x and 4. Let's just call it what it is. This is x plus 4. And because it's a rectangle, this is x plus 3. And this is x plus 4. And if I wanted to know the area, all I do is multiply length times width. I might have mixed those up, but in the end you'll get the same thing. X times x times 4, 3 times x, 3 times 4. X squared, 4x, 3x, and 12. And we have some like terms. 3 and 4 make 7. There we go. And we also have a perimeter to deal with. I won't erase anything. We'll just write it over here. We'll switch colors there, just because I should. So the perimeter is going to be all the sides added together. So it's x plus 3 plus x plus 4. Put them in parentheses if you want to. X plus 3 again. And x plus 4 again. And we're going to, excuse me, we're going to add all the like terms together. X plus x plus x plus x. I have 4 x's. And 3 plus 4 plus 3 plus 4 is 14. So there is our perimeter. That's it.